So yeah, hi. Good afternoon, everyone. I'm Christoph Bohr. I'm the head of chemical technology at Solaveni. Today, I want to show you a bit about our synthetic approaches for products, our sustainability goals, and how we handle the recycling research. And I want to give you a short insight in our company. So Solaveni is quite new. We were founded in 2021 by General Oetz, and we are a spin-off company of Saule, as I just mentioned. And we originally was founded with the idea to focus on the chemistry side, on the material side of perovskite technology. But we are not only selling or providing our materials and products to Saule exclusively, but we're selling to our academia and industry worldwide. So Solaveni more or less is focused on three pillars. The first one is like the production of nanoparticle dispersions, for example, or perovskite precursors like lead iodide and methyl ammonium iodide and such. The second one is the research and development pillar, which mostly focuses on the recycling of perovskite and other materials. And the third one is we have a marketplace for materials as well, which we do not produce ourselves, like, for example, PCBM, Spiro, or whatever you need on the organic side there. Or as we also have like a cooperation for providing blade coaters, for example. So as I just said, the first pillar deals with our perovskite precursor materials. And we have a patented process where we can produce the common perovskite precursors way more environmental friendly compared to the conventional process. We are very cost effective since we only have one reaction step involved, and we yield very high purity products here. These processes are very scalable, so we can provide on a ton scale already to industry. And on another note, we also have like the nanoparticle dispersions, like this tin oxide, colloidal tin oxide dispersions, which are, as you all know, have been provided to a competitor which is not holding up to the quality it has. So if you need some, give me a call. Back to the precursors. Here's a comparison of the conventional process to our Solaveni process. We do not need any critical solvents like in the conventional one, like H2S or diethyl ether, for example. It's a very fast reaction, and I already said that it yields high purity products. For example, we do not need any HI stabilizers, which are usually used in the conventional process. And it's a quite universal applicable process. And we already tested more than 40 compounds, and we think the list is growing fast. The process is even more impressive if you compare it for the inorganic halide precursors. Here, you can, let me check before the laser pointer, maybe this helps a bit. If you see the conventional process, a lot of steps are involved here. We have still the same process like for the organic ones, just one reaction step and a bit of cleanup. So it's a very energy efficient, low emission process. Again, no harmful solvents involved. And I can show you a bit better if we go for the next slide. And we did a life cycle assessment analysis in cooperation with the Oxford Brookes University. And we tested 13 impact categories. And we excelled in 13 of all the 13. So since one of the major points is that we don't need this diethyl ether here. In total, we are 87% better on the environmental impact. So we were quite surprised that it turned out that well, but yeah. Let's maybe, in the interest of time, come to the recycling already. As we know, the perovskites, which will be used in the industry in the beginning at least, will definitely contain lead. Lead is quite toxic, so it poses a severe health risk. So it needs to be dealt with properly. We know that in the processing of the solar cells, still harmful solvents like dimethyl formamide, or DMF, or DMSO are mainly applied. but they are not